Yes, hello. We separated this talk into two parts. I will start explaining the basics, so you can understand why there is a need for GeoServer Cloud, how it works, what problems are solved. And then I will pass over to Alexandre Gacon from Camp to Camp. He will show some case studies and share practical experience. So I will talk about, or we will talk about GeoServer Cloud. A few words to me. My name is Nils Bühner. I'm software engineer and developer for Terrestris, company settled in Bonn, Germany. And yes, I'm maintainer of the traditional GeoServer Docker file. I know there are many, but let's say the official one. And I'm also contributing to the GeoServer Cloud project we are talking about. I decided to start this talk with this picture. We had a code sprint last year. Unluckily, Alexandre is not on that picture, but he was also there. Because I want to clarify, GeoServer Cloud is not my baby. The main work of GeoServer Cloud was done by Gabriel Roldan from Camp to Camp, who is on the right side, the guy on the left. He's also core developer of GeoServer for, I guess, more than 20 years now. And it was a great week in Chambéry, France, in the offices of Camp to Camp. It was a really great, funny week we had. Yes. So what will I talk about? I will first explain why there is a need for GeoServer Cloud. We will see the architecture and talk about the different things that are have been done in the GeoServer Cloud project. I will name the most important features. And I will also talk a bit about extensions, GeoServer extensions, because I guess most of you know GeoServer, maybe who did already use GeoServer? Okay, that's what I expected. So you know there are extensions for GeoServer, but in GeoServer Cloud, as we have a distributed environment, things are a bit different. So that's what I will talk about, and then I will pass over to Alexandre to see the case studies. Yes, you will find these slides. They are HTML-based on GitHub. Yes, but we also converted to PDF and uploaded them on the platform. Yes, so let's start with traditional GeoServer. The GeoServer project has grown for more than 20 years. It's matured, and I think it's proven and stable in production. As you know, all those common OGC standards, WMS, WFS, etc., are all well implemented in GeoServer. There are many extensions, stable extensions, community extensions, and there's also active development going on. So maybe some of you also attended these GeoServer talks yesterday, and there's a big change coming up with GeoServer 3, which maybe will also have impact here on this project. So why there is a need for GeoServer Cloud? I mean, you all know that cloud technologies in the past years became increasingly important in modern GIS architectures, but traditional GeoServer is not cloud native because it started 20 years ago and nobody had cloud environments at that time. Traditional GeoServer is a monolithic application, and there's a lack of native support for horizontal scaling. When I say horizontal scaling, I mean we want to start multiple instances of GeoServer, where vertical scaling would be raising hardware, memory, CPU. But yes, what we want to do here is we want to scale horizontal. So let's imagine to scale the traditional GeoServer. So what you could create, I created this graph. It's not GeoServer Cloud what we see. It's just, in theory, if you would try to scale the traditional GeoServer, you would have incoming HTTP requests against GeoServer, and then you would probably have some kind of gateway, load balancer, proxy, whatever. And then, of course, in the underlying level, you would have these GeoServer instances. Okay. And then GeoServer uses this GeoServer data directory, which is a directory with a lot of XML files that contain all the information of the GeoServer configuration, or the GeoServer catalog, for example, data stores that are connected, layers that are published, styles, and whatever. And yeah, you could say, I will share this data directory in the network, and then all of these instances can use it. So far, so good, but this is a lot of pain. I mean, we would still replicate the full stack of GeoServer with all the baggage. And what you should know is that if you have a look at this picture, we have this block at the bottom in the middle, the now shared catalog, which, as I said, is just a directory with a lot of XML files. But GeoServer, when it starts or whenever you change a setting or publish a layer or whatever, it will always load this catalog into memory, which makes sense because you can work efficiently on memory. And the problem is that updates on one instance won't propagate to others. So all the other instances remain unaware of changes and would continue working on their now outdated memory state. So for example, if the second GeoServer in the middle would be the one that is used to update something in this catalog, then for this instance in the middle, everything would be fine. But the first GeoServer on the left side and the others on the right would just not know that something had changed, and they would still operate on the outdated memory state. So what could help in such a situation? You could try to find time-consuming, error-prone approaches, like, for example, prepare your data directory in another environment, and then you would only use a read-only shared data directory. You could also create scripts or tools to maybe periodically check for updates. So there is an XML file which has an update sequence, so it would be possible to recognize changes, and then there's a REST API, and you could trigger a reload on all other instances. But you will pretty sure get other problems then. So yeah, the solution for these problems is GeoServer Cloud. So GeoServer Cloud is a scalable GeoServer based on a modern microservices architecture. There's a service discovery, message broadcasting, an event bus, and yeah, this is technically done by heavily using the Spring framework. Spring Boot is a bit too specific here because the Spring framework in the Java world, yeah, it's not only Spring Boot, it's Spring Cloud, Spring Data. There are many libraries with really best practice implementations. Yeah, and we also have in the GeoServer Cloud project, we also have these cloud optimized features. For example, there is a more performant catalog access. There's even a different catalog backend implementation, which is not based on XML files, but a database. And of course, all of this is cloud native and DevOps friendly. And in the talk just after me, Alexandre will also show how you can easily use GeoServer Cloud with Docker and in cloud environments. So yeah, let's have a look at the architecture. Luckily, the traditional GeoServer base code, core code is highly modular. So it's a Java project. It's organized as a Maven project. Maybe some of you know this. So the code in general is highly modular. And what GeoServer Cloud does is it just picks up those core implementations and, let's say, repackages them to independently scalable, loosely coupled microservices. So we will now have I don't know if you can read this, but we can see this block here. So we will have a microservice for WMS, microservice for WFS, microservice for the REST API, for the web UI, and all of these microservices, single purpose microservices, can be scaled individually. Yeah. On top of that, GeoServer Cloud adds features like the service discovery, which means whenever a new microservice or instance of such a microservice is spawned, for example, during runtime, then this would be registered or discovered by the service discovery. And then whenever something happens, for example, an update in the data directory or now in the database better, then all the other instances can be informed using this event bus messaging. And then they can also reload immediately to be up to date. Yes. As I said, there's an intense use of the Java Spring framework, Spring Cloud, Spring Cloud, whatever, Spring Cloud. And what's also new in GeoServer Cloud is that you can configure, so you have a configuration, especially for GeoServer Cloud, which is what you can see on the right side in this block, in the infrastructure block, which is indeed the code that is new in this project. It's not a new implementation of GeoServer because the core code is reused, but it's something on top, and it's just this repackaging into microservices. And for example, it's now possible to activate or deactivate, configure certain functionality. For example, you can not only activate or deactivate certain services, which of course you can also do with the traditional GeoServer, but you could also activate or deactivate certain data formats, output formats, whatever, a lot of things, extensions, which we will see soon. And of course, you have health checks, metrics, and everything that you need in the cloud or want. Yes. So this is just a screenshot to demonstrate that you can have a cluster with multiple instances. For example, in this case, two WFS microservices, two WMS microservices. And if you have a look at these addresses, you will see that they live in different networks, just to demonstrate. And this page is not available in the traditional GeoServer. This is just a new entry. You can see it on the left side here in GeoServer Cloud, because of course, this is something that doesn't exist in GeoServer, in the traditional one. So yeah. So what are the main features? There are many features, and I think we could not really list all of them, or we could list them, but the time is limited, and I will have to hurry. Yeah, there's especially this PostgreSQL-based GeoServer catalog backend, which can be used to replace this XML-based data directory, which of course makes sense here in a distributed environment. But you can still use a shared XML-based data directory by just activating the profile for this. So maybe you want to migrate from traditional GeoServer to GeoServer Cloud, then Alexandre will have a talk tomorrow about migrating and synchronizing GeoServer with Terraform. And I also created a small Python script just 2 weeks ago to migrate data from one GeoServer to another GeoServer, which makes sense now if you have a different backend for the catalog. It's just fetching on one side with the REST API and posting it to the other side. Then you also have GeoServer ACL. ACL is Access Control List, which is an advanced authorization feature for GeoServer. Maybe some of you know the GeoFence extension for traditional GeoServer. This is just, let's say, a fork of the GeoFence project. And you can configure very fine granular on attribute level, on layer level, service level, which role of authenticated users should see which area, which data, which attributes, whatever. You can do a lot of things here. And also the GWC, GeoWeb Cache integration is also compatible in GeoServer Cloud. Now we come to the extensions, because I think this is one of the first questions that comes up if you want to migrate to GeoServer Cloud. What about my extensions? I'm using these and this extension. I also want to use it in GeoServer Cloud. What can I do? What you see here is the list of supported extensions currently right now, and there are probably some more. But as we have a distributed environment, things are different. So if you have a missing extension, you still need some dev effort. There was a big refactoring in April. It's not that hard, but of course you still need some knowledge. It's not so easy as it was before, where we just dropped a file in the correct location and then started your GeoServer. Now you have to add your extension model, your starter module, which is all happening in the Spring framework context. And then you have the possibility to activate or deactivate your extension and use it or not use it. Now I will pass over to Alexandre. If you have questions, just later or later. Thank you.
Thank you, Nils. So I will present now several case studies which are using GeoServer Cloud in production to see what they bring to the different customer we try to serve. So first, patient zero, which is for a French digital agency for civil security. We help them to develop the Nexus project, which is a unified operation system for firefighters in France. So the challenge was to manage a dozen of different environments. We have several development environments, half a dozen staging environments, and several production environments. Since if it is for firefighters, we don't want any downtimes when we do updates. We want to be able to scale the environment when there is some exceptional event like a forest fire or terrorist attack. And they have decided to use Kubernetes, so we have to deploy it on Kubernetes. So the solution was to initiate and fund the development on GeoServer Cloud. So they were the first customer, and they found a great part of the basis of the project. They also found the GeoServer Cloud Helm chart to help deployment on Kubernetes, and also Terraform provider to have the configuration of the server to be deployed as code. The result is that we have simplified deployment and maintenance. We have a lot of good responsiveness when the workload changes. Currently, it's on production. It covers 5 million people in France, which is about 9% of the population for now, and we are going to grow up in the next coming years. So, just to show you what it can look like, we have several dozens of different type of information which is shared. The second case study is some scalability for Deutsche Telekom FTTH. The challenge, they have people, analysts, we generate for scenario planning a lot of layers, more than 500,000 for each scenario. The problem that it's something which GeoServer vanilla has difficulties to manage, to add so much layers and to load. And they were also using Postgres raster, which is not very performant. So the solution we provided is to move to GeoServer Cloud with a Postgres catalog backend. And also we make them use Koch files on S3 instead of using Postgres raster. The result is now they have nearly real-time generation of dynamic layers, and they can quickly use the result of the simulation. And it's they also have more. It's more cost efficient for them and more scalable. Second case study: multi-tenancy advanced security for Veolia. They want to secure multi-tenant geospatial data access and reduce the number of technology for business application. They had at this time application based on GeoServer, over on S3 stack, over with only Google Maps, and we want to have only one technology stack to manage all their different business cases. And they want to improve scalability. So we help them to migrate to GeoServer Cloud with Kubernetes on GKE. They initiate a fund GeoServer ACL for the security. And now they have a unique special provider for all the business applications they have. And they have also simpler update and deployment by using the Terraform provider. We also work with Deutsche Telekom R&D for also for security. They had different GeoServer vanilla instances to separate security access to internal operation, external collaborators, which make them more difficult to manage their IT infrastructure. So we suggest them to implement GeoServer Cloud with GeoServer LCL. They use also an integrated OpenID authentication on top of GeoServer. And with that, they have only one IDS to SDI to manage with secure and access to collaborator. And then now they can control correctly all the, we have in one place who can access which information. And last case study for a major insurance company. They have a cluster with dozens of GeoServer instances with static cluster, and like Nils explained, it's quite difficult to manage. So they have manual triggering of configuration update. They have long startup and reload time, so sometimes over 1 hour per instance. So solution, we migrate to GeoServer Cloud with Kubernetes, with Postgres catalog, and with dynamic scaling, horizontal pod scaling, and reality configuration update. Now there are startup time reduced to seconds. Deployment and maintenance is really simplified, and also they have a good responsiveness to workload changes. And thank you for your attention.
Thank you. Any questions?
I just wanted to ask how much new microservices will appear with the new Geo API and GeoServer? How much more new microservices will appear in the GeoServer Cloud architecture when the Geo API will be part of GeoServer? Will you implement this?
There is no plan to have this, I think, for the moment. You mean Geo? Normally, it depends on how you you should have you have the gateway which is displayed, and you won't have many instances. It will be part of the gateway which serve all the underlying microservices. You don't attack each microservices. You are. I think that there will be some stuff on the gateway part. Not sure, but we have to ask developers, I think.
Yeah, thanks for the presentation. I've recently come across the GeoServer's message-oriented middleware, which serves exactly the same purpose for horizontal scaling. Are you aware of that message-oriented middleware? I haven't used it myself, but it's supposed to serve exactly the same purpose.
You have solution to have active cluster with using also a messaging queue to inform each instance of GeoServer, for which you can reach some kind of capacity of what we have, but you won't have microservices. So, for example, if you only serve WMS, you can't say I only want several additional WMS services. You have only as much as your server instance you want, and also you won't have, for example, the PG catalog, which is better for reloading stuff. So you can reach, if you have perhaps not a large number of layers, but you will at a moment reach a limit for which you can't scale more without going to a cloud solution like GeoServer Cloud, I think.
So definitely your recommendation to use GeoServer Cloud.
If you need it. If you stay at the following presentation, you will see it depends on your use case, like any tool.
Thanks.
Yeah, thank you very much for the presentation. You mentioned that you have this migration tool. Is there anything besides that I have to do when I want to migrate from an existing traditional GeoServer to GeoServer Cloud?
It could, depending on how you store your data. If you are only on database, on something on which is on a network, or even on cloud-oriented format, it should be easy to migrate. If, for example, you are using geo packages or shape files, you have to figure out how you can share the access to the different pods. So it could be more difficult to do that. So perhaps the first step indeed is try to have something more server-oriented, like having a database and using something on the network or cloud-oriented for raster, for example.
Thank you.
Hi, we had a pretty complex ACLs on geofence with few thousand users and the rules based on services and workspaces and so on. And we gave up on cloud few months ago because there was no way to implement this. Now I see that this is developed. How hard would be now to migrate existing geofence database to this ACLs?
I'm not sure it is planned. I'm not sure there is a tools for that. We can perhaps using the REST API could be a solution to work. I don't have the use case, but I don't think the database will migrate by itself. We can ask Gabriel if he have a solution later. But for the main stuff I think is to use the REST API to have tools to do the translation. Okay. And we don't have such a tool for the moment.
Migration.
But don't hesitate to ask a question on the GitHub issue. On the GitHub repo, there is an issue, so don't hesitate to ask the question.
I will follow.
And we'll be happy to forward to Gabriel.
Thanks.